Cable types and connectors, network and fiber. In this lesson, we're going to cover different cabling types and connectors. Now, in this course, we have talked about networks and different network components and network devices. We're going to take a different turn in this lesson and learn about the connectors and the cabling that's basically the backbone to the networks that we've been discussing. And we're going to start our discussion talking about Ethernet. Now, we're going to start off with some background about Ethernet because today, when we say Ethernet, we're really not talking about the whole scope of Ethernet. So let's get started. So, Ethernet is the traditional technology for connecting wired local area networks, LANs and MANs and wide area networks. Ethernet cabling really is the backbone. But actually, Ethernet is not a cable, more or less, it is a protocol. Ethernet is a protocol of families that falls under the IEEE 802.3 standard. Now, the Ethernet protocol was developed in the early 80s. Ethernet is a communication protocol that ensures reliability through its systematic delivery of frames and packets of data. Ethernet touches two parts of the OSI model, the physical and the data link layers. So, Ethernet actually is a connection protocol. And I know commonly nowadays we may refer to an Ethernet cable and a cabling or Ethernet. But Ethernet actually is a communication protocol, not just a cable. The twisted pair, which we're going to learn about in a little bit, is just one portion of Ethernet. So originally started as a coaxial cable because of that communication protocol. It's a connection medium, not just a cable. Widely used in modem wired networks. Most common connection speeds for Ethernet are 10 base T, 100 base T, 1000 base T. All of these are collectively known as Ethernet. So the most common connection medium that we're probably used to today is copper twisted pair. So that's where probably the confusion, where a lot of people call the twisted pair Ethernet. Yes, it is a Ethernet cable, but Ethernet is a protocol, a communication protocol, not a cable. Since its iteration, Ethernet went through various upgrades and changes. No matter what different cabling or devices are used, the network host will still be able to communicate over the communication protocol Ethernet. So let's dig into the cabling portion of it now. Now, first, let's look at unshielded twisted pair. So, unshielded twisted pair or UTP cabling is the specified cabling for the 10, 100, 1000 base T networks. So, this is really the most common cabling that we use today. And you've probably seen that as an Ethernet cable. Twisted pair actually is cabling consisting of a gauge of 22 to 26 gauge wire twisted together into color coded pairs. Each wire is individually insulated and encased as a group in a common jacket, as you see here. Now, we had untwisted pair. There's also something called a shielded twisted pair. Shielded twisted pair consists of twisted pairs of wires surrounded by a shielding to protect them from EMI or electromagnetic interference. STP is used in locations with excessive noise, electronic noise, such shop floor, places where there's a lot of fluorescent lights, electric motors, and other machinery that can cause problems for cabling. Early in my cabling and installation years, if you take unshielded twisted pair or UTP and run it over fluorescent lights or close near fluorescent lights, you get a lot of noise on that wire, a lot of interference. Shielded twisted pair or STP cabling alleviated that. Also, there is a type of cabling that you can directly bury in the ground without a conduit. It's Ethernet direct burial. Now, it's designed for outdoor use and it's laid in the ground without a conduit. You can lay it directly in the ground. It's basically constructed with a special UV resistant polyurethane jacket. It's waterproof and handle temperatures as low as a negative 40 degrees Fahrenheit as well as Celsius. Now, there are times when you have to run cabling in ceilings or in walls. Sometimes, depending on the code and the nature of the business, that cabling needs to be fireproof or fire rated. That's where plenum and non plenum come into play. So, network cable that is running in spaces is called plenum. Plenum is that space of that air between the roof and the ceiling, or above the ceiling tiles or above the ceiling. So plenum cable is that special cable with that special jacket that prevents it from catching fire quickly. It's a fire retardant built into it. So it's manufactured with a PVC polyvinyl chloride jacket material. So when it's burned, when normal cable is burned, it lets off noxious fumes. But plenum is fire retardant, and that cabling jacket is a plenum grade cable where it does not burn. So plenum grade cable costs a little bit more than non-plenum, and you would use these for specific places that calls for a fire retardant cabling, such as in hospitals or medical offices, any places like that. Certain businesses require plenum cable as well. So you when you come across network cabling, you're going to see network cable rating stamped on the cable. It'll identify the type of cabling, whether it's the STP or UTP cabling. It'll also have other information of that rating of the cable on that casing as well. Um, Distance limitations has a 100-meter distance or 328 feet. You can't pull Cat 5 or network Ethernet cabling further than that distance. Different application types based on the cables. And also, cables have evolved based on the technological advances. We'll see that in here in a little bit. So these are the different cables that has been upgraded over the years. And these are known as Cat 5 or category cables. So say for instance, you have your uh, Cat 1, Cat 2, Cat 3, and Cat 4. Up until this time, today's time frame, those were the older type cables. We use them for token ring networks, old telephone cables. We're really primarily consisted of learning about Cat 5 through Cat 6A. So Cat 5 is the most common cable that's used today. Its data rate is up to 100 megabits per second. The maximum length is 100 meters, which we just learned 328 feet. It's twisted pair. And you can use that cabling, Cat 5 twisted pair, for Ethernet, fast Ethernet, and token ring networks. Cat 5e came a little bit later, and that's an enhanced version. Enhanced is up to 1 gigabits per second. Same distance limitations of 100 meters, twisted pair still, and as well as same networks, Ethernet, fast Ethernet, and gigabit Ethernet. Then, as technology advanced, we needed way to move more data over twisted pair. So that's where Cat 6 came into play. Cat 6 improved our throughput up to 10 gigabits per second. Same distance limitation, same twisted pair, but now it's rated for gigabit networks and 10 gig Ethernet, and that's only rated to 55 meters. As technology evolved, now we're up to Cat 6A. Cat 6A provides a little bit even more components and features than Cat 6, up to 10 gigabits per second for data rate. Still same limitation of 100 meters, twisted pair, and it can be ran over gigabit Ethernet, 10 gig Ethernet, and has that distance limitation of 55 meters. So that's the technology of the cables that we're using today. Now, looking at the cable ends, we talked about there's different color codings to those cables or different pairs. The reason why there's different pairs is there's different configurations that you can arrange the cables in or different specifications. So we have the T568A and the T568B standards. Now, the T standards are governed by the Telecommunication Industry Association or TIA. It's ANSI TIA 568 specification. Now, there's two standards for the RJ45 UTP cables. That's the T568A and the T56B. Now, there's different color codings, either the same twisted pairs, but in the way that you arrange the cables is this different specifications, which we'll learn here a little bit. Now, the US government requires T568A type wiring or configuration, where some organizations may standardize on the T568B. Now, if we look at the diagrams, again, it's the same cabling, but the pairs are switched. In the 568A cable end, you'll see that the pairs start off with the white green wire, then the green, then the white orange, and the blue, white blue, then the solid orange, then white brown, then the solid brown. Now, 568B wiring is a little bit differently. That starts off with the white orange pair. White orange orange, then it has the white green green, then it has the blue, green, white, brown, and brown cabling. Again, different specifications, different applications, same wire. The data flows through the same. The data rate is the same, but some organizations require the color code to be standardized one certain way, and other organizations require it to be other ways. At the end of those cables, you're going to put what's called a connector on it, whether it's a twisted pair category 5 type cable or a phone cable that only has two pairs. So you're going to use either an RJ11 or an RJ45. For the RJ11, which is the telephone equipment cable or telephone wire, it's used primarily for telephone equipment, supports up to two pairs of wires, and it also can transmit data as well as telephone and voice. The RJ45 is primarily used for network cabling. It supports up to four wires of cables or four pairs of wires, and it's standard for the UTP and STP cabling. Coaxial cable. Again, coaxial cable is a total different construction of cabling. However, it does fall in within the Ethernet family. Now, coax is a little bit differently because it's constructed with a center cable or core surrounded by insulation. Early Ethernet ran on actual coax cable. There are many RG ratings for the coax, but only for the CompTIA, we're concerned about the RG59 and the RG6. Both RG6 and RG59 have a 75 ohm impedance. RG59 is thinner and doesn't carry data as quite as far as RG6. The RG6 rating is clearly marked on the cables. And these are the connectors for coax. You have the F type female and the F type male. And also, you have what's called a BNC connector, which is a connector that has like a twist that you connect the two wires together. And the last type of cabling we're going to discuss is the fiber optic cable, optical or fiber optic cabling. Now, again, fiber optic is a little bit differently from the other cables because it uses light instead of electricity through a copper wire. Um, it's immune to electrical problems and it travels much further, up to 2,000 meters or more. And there's different types. There's multi-mode and single mode. Multi-mode uses light emitted diodes or LED, and it sends multiple pairs of lights down the cabling to connect to the other end and pass traffic. Whereas the single mode uses a single laser light, and that single laser light is sent down that cabling to connect to the other ends. And these are the ends that you would use for fiber optic. There's different type of connectors that you use for fiber optic cabling. So first you have is the ST or the straight tip. And this is the most commonly used connector that's used for fiber optic cabling. It's like a twist and lock connector. Then you have what's called the subscriber connector or the SC. And this is used in the single mode fiber optics. Next, you have the LC, and this is a small form factor. It's a lucent connector, LC, uses 1.25 millimeter ferrules. And this is used in transceivers, fiber to the home. You'll see this a lot in smaller devices like trans receivers and so forth. And finally, you have the FC or the ferrule connector, this which is not really used widely today. You still may come across it. It was replaced by the SC and the LC. So we have went through our different network cabling and network cabling connectors. And again, the Ethernet standard covers many different cabling types. It covers twisted pair, it covers coax, and as well as the fiber optic. That communication protocol is used to send communication down all of those type of cablings. So that is it for this lesson, and I will see you in the next lesson.